We import TensorFlow as TF. Then we print out the version of TensorFlow we are using. We are using TensorFlow 1.5.0. In this video, we're going to use the TensorFlow reshape operation to infer a tensor's new dimensions when reshaping a tensor. This is useful in scenarios where you know some of the dimensions that you need the tensor to be in, but you don't know all of the dimensions. Let's start out with our initial TensorFlow constant tensor that we'll later reshape. We create a tensor shaped 2 by 4 by 6 with numerical integer values between 1 and 48, all of which have the data type int32. We use tf.constant and we assign it to the Python variable tf initial tensor constant. Let's print out the tf initial tensor constant Python variable to see what we have. We see that it's a TensorFlow tensor, we see that the shape is 2 by 4 by 6, and we see that the data type is int32. Because we haven't run it in a TensorFlow session, it doesn't have values yet, even though we just defined it as a constant. The same will apply to the other reshapes we're about to create. For the first example, let's say that you don't know what the initial tensor shape coming in is. We just know that we want it to be a 2 by 12, and then the third dimension can be figured out. So we'll be going from a rank 3 tensor to a rank 3 tensor. So we use TensorFlow.reshape. We pass in our initial tensor constant, and we want the shape to be 2, 12, -1. By using this -1, we're telling TensorFlow to infer from the tensor we pass in what the third dimension should be. So we're going to assign that result to the Python variable tf x1 reshaped tensor 2 by 12 by x. Let's print out this variable to see what we have. We see that it's a TensorFlow tensor. We see that the data type is int32, and we see that the shape is 2 by 12 by 2. So you can see that TensorFlow automatically inferred that the third dimension should be the number 2. And this makes sense, because 2 times 12 is 24, and since there are 48 elements, because our initial shape was 2 by 4 by 6, so 8 times 6 is 48, so 48 divided by 24 is 2. For the second example, let's say that you don't know what the initial tensor shape coming in is. We just know that we want it to be 6 by another number. So we'll be going from a rank 3 tensor to a rank 2 tensor. So we use TensorFlow.reshape, we pass in our initial tensor, and we say that we want the shape to be 6, -1. Again, remember that we use the -1 to infer the shape that will be used. We assign it to the Python variable tf x2 reshaped tensor 6 by x. When we print this variable, we see that it's a TensorFlow tensor. We see that the shape is 6 by 8. So you can see that TensorFlow automatically inferred that the second dimension should be the number 8. And this makes sense because 6 times 8 is 48, and since there are 48 elements, it means that 48 divided by 6 is 8. Also note that TensorFlow didn't complain about going from a rank 3 tensor to a rank 2 tensor. For this third example, let's say that you don't know what the initial tensor shape is coming in. We just know that we want it to be a 2 by 2 by 3 by another number. So we'll be going from a rank 3 tensor to a rank 4 tensor. So we use TensorFlow.reshape, we pass in our tf initial tensor constant, and now we're saying that we want the shape to be 2, 2, 3, -1. Remembering that the -1 tells TensorFlow that we want it to infer the shape of this dimension. Then we assign it to the tf x3 reshaped tensor 2 by 2 by 3 by x Python variable. Then we can print this variable, and we see that it's a TensorFlow tensor. The shape is 2 by 2 by 3 by 4. So you can see that TensorFlow automatically inferred that the fourth dimension should be the number 4. And this makes sense because 2 times 2 is 4, times 3 is 12, and 12 times 4 is 48. And since there are 48 elements, it makes sense that this number would be the number 4. And again, note that TensorFlow didn't complain about going from a rank 3 tensor to a rank 4 tensor. Now that we have created our TensorFlow tensors, it's time to run the computational graph. First, we launch the graph in a session. Then we initialize all the global variables in the graph. Next, we're going to print out our 4 tensors to see how TensorFlow's reshape works when we ask TensorFlow to infer a dimension. We print our initial tensor to remind ourselves what it was. So we see the numbers 1 through 48, and we see that it's 2 by 4 by 6. Let's now print our first TensorFlow example, which was tf x1 reshaped tensor 2 by 12 by x. When we do that, we see that it is a tensor that contains two matrices. The first matrix has 12 rows and 2 columns. The second matrix has 12 rows and 2 columns, and all our 48 numbers are there. So we see that TensorFlow was able to adapt to the dynamic shape requirement and inferred that the correct number of columns was 2. Let's now print our second TensorFlow example, TF x2 reshaped tensor 6 by x. Awesome. We see that it's a tensor that has one matrix. The first and only matrix has 1, 2, 3, 4, 5, 6 rows, and 1, 2, 3, 4, 5, 6, 7, 8 columns. And all our 48 numbers are there. We see that TensorFlow was able to adapt to the dynamic shape requirement and inferred that the correct number of columns was 8. Finally, let's print our third TensorFlow example. This was TF(x3) reshaped tensor 2 by 2 by 3 by x. When we see that it's a tensor that has two interior tensors, each of which contains two matrices, and then another two matrices here, so 2 by 2 by 3. Each of these internal matrices has 3 rows and 4 columns. And we see that TensorFlow was able to adapt to the dynamic shape requirement and recognize that we wanted to increase the rank of the tensor and that the correct number of columns for the fourth dimension was 4. Perfect, it worked. We were able to use the TensorFlow reshape operation to infer a tensor's new dimension when reshaping a tensor.